All right, guys, let's take on this next resistive circuit here. Number 12, we're going to tackle this the same as we did number 11. First, what we're going to do is we're going to draw in where our parallel nodes are. What is going on today? Da, 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 da. Okay, so we need a parallel node right here, and there's another parallel node right there. What do I mean by that? I mean that current is going to go in two different directions there. Okay, at that point, we're going to look at the circuit and we're going to say, all right, is anything in series that we can add up? Well, 3 and 4 look like they're in series, so we'll add those guys up. And we'll make a note of the addition of those guys. 10 plus 10 gives me 20 kiloohms in this rung. Okay? Nothing's working out today. Come on. Beauty. Okay? This one is another, well, not complicated, but harder one where we're trying to find this without a calculator. So there's got to be a pattern here, similar to the previous one. I'm having a stroke today. I can't even talk. So we got 20 kiloohms and we got 20 kiloohms. Those guys are in parallel. So if we have two values at 20, then we know that the total resistance is going to be the 20 divided by the number of paths. It's going to give us a value of 10. Okay, so R3, R4, and R5, the combination of those guys is the same as a 10 kiloohm resistor. Beauty. So we're going to write that in here, 10 kiloohms. And then we're just moving our way up. We're going to go through this other resistor in series. So 10 kiloohms for 3, 4, and 5, plus the 10 kiloohms for R2 gives me 20 kiloohms for all this noise down here. Let's see what's in this rung over here. We've got another 20 kiloohm resistor. Beauty, we have the math over here. 20 and 20 divided by 2 paths gives us 10 again. So at each point I'm just writing down the value that I have below there. Nice. 10 kiloohms plus the 10 for R1 gives me a total of 20 kiloohms for the whole circuit. Excellent. See how fast it is? Before it would take you like 10 minutes to do a circuit like this. Now we're rocking through. We're at 2.5 minutes. Last thing we need to do is find our current. 2 8-volt single phase divided by 20,000 ohms. Okay, so if we want to find the total there, then we can take the 2.8 divided by 20,000 ohms, and that's going to give you, well, let me write that in there because I usually do the kiloohms here, but let's do 20,000 ohms. Right, because that's what 20 kiloohms is. And if you go 2.8 divided by 20,000, that gives you 0.0104 amps. Beauty. If we wanted to do that 2.8 divided by 20 kiloohms, then we would be divided by thousands of ohms, and we would get, let's see, 1, 2, 3, we would get 10.4 milliamps. These guys are the same. Okay? Excellent. Doesn't matter which form you give it to me on the test. Everything's fine. 10.4 milliamps or 0.0104 amps. They're both the same value. All right, guys. Hopefully you're seeing the patterns now. So stop this guy and then move on to question number 13.